Hello, this is Calculus Early Transcendentals, and we are discussing the applications of the derivative. And today is on section 4.4, L'Hopital's rule. I'm going to cover a couple of short videos on L'Hopital's rule since there are a lot of different rules to go along. But the main rule is that if we've got a limit of a quotient, if we have limit as x approaches a of an f of x over g of x, and that limit approaches a 0 over 0 or approaches infinity over infinity, then we can apply L'Hopital's rule and state that the limit is equal to the limit of the derivative of f of x over the derivative of g of x. This is not the quotient rule. It's just take the derivative of the numerator over the derivative of the denominator. You can only use L'Hopital's rule if you end up with a limit that's going to 0 over 0 or infinity over infinity. Otherwise, if you get a number over 0, then you'll be claiming it's positive or negative infinity. If you have 0 over a number that's not equal to 0, then you would have 0. If you have a number over infinity, it's going to 0. If you have infinity over a number, it would be going to infinity. So you will, and if you get a number over a number, you would be going to that number. So other limit rules that we've been studying from chapter 2 still apply. It's just that if you meet the criteria of L'Hopital's rule of having a limit of 0 over 0 or infinity over infinity, then you can use the rule. Otherwise, you cannot. All right, so be careful with that. I'm going to jump ahead to other indeterminate forms because we have gone over in class when we do have the 0 over 0 or infinity over infinity. So I'm going to jump ahead to what happens if we end up with 0 times infinity when we're taking our limit of f of x times g of x, or even an f of x over g of x. Well, then we're going to use an algebraic manipulation to turn it into a limit that will go to 0 over 0 or infinity over infinity. Because let's say, for instance, we do have the limit as x approaches a of f of x g of x, and if our first approach is to evaluate f at a and evaluate g at a, but let's say it goes to 0 over infinity, or 0 times infinity, excuse me. And if we look at that as like an a times a b, notice that if we rewrite a times b as a divided by 1 over b, then this would be a 0 divided by 1 over infinity, and that would be a 0 over 0. We could also rewrite a times b as b over 1 over a, and recalculating that, we know that b is infinity, and we'd have 1 over an a is 0, and this would be an infinity over an infinity, and then we could apply L'Hopital's rule to that new expression. All right, so let's take a look at this example here. The limit as x goes to infinity of x times sine of pi over x. If I plug in my value of infinity, I'm going to, x is going to infinity, and sine of pi over infinity, that is going to infinity times sine of 0, and that's going to give me infinity times 0. So I'm going to rewrite this product in a new way by using that a times b, and I'm going to take the x to the denominator. So I'm going to say this is equal to the limit as x goes to infinity of sine, and I'm going to rewrite pi over x as pi times x to the minus 1, just for the next steps in applying L'Hopital's rule. And taking x to the denominator, it becomes x to the minus 1. And now I know, just based on my algebraic manipulation, that L'Hopital's rule applies. And so here I go, taking the derivative of the numerator, and the derivative of the numerator involves the chain rule, and we have cosine evaluated at pi times x to the minus 1, but then times the derivative of the inside, which ends up being minus pi times x to the minus 2. And I'm going to take the derivative of the denominator, and the derivative of the denominator is minus x to the minus 2. That was me taking L'Hopital's rule. I'm going to clean things up. I can see that I can cancel factors of x to the minus 2 and x to the minus 2. I can also cancel my minus 1s and minus 1s, and so that's going to be a plus and a plus. And now I'm going to try again, and when I calculate my limit, I'm going to cosine of pi over infinity times pi over 1, right? And because we don't have any other denominator. And that is going to cosine of 0 times pi, and we know that cosine of 0 is 1, and 1 times pi is pi. Okay, so that's how we handle indeterminate products. All right. One more here, so we can be pretty good at our stuff. All right, so here, if I'm going to negative infinity, we just want to make sure what kind of form we have. We always want to see if we do have an indeterminate form, or if we can go ahead and calculate the limit as usual. So here I'm going to minus infinity cubed times e to the 3 times minus infinity is minus infinity. And that is going to negative infinity times 0. So I do have that indeterminate product, and I'm going to choose to put the e to the 3x to the denominator. So I can say that this is equivalent to the limit as x goes to minus infinity of x cubed over e to the minus 3x. And we know that L'Hopital's rule applies because we will end up with an infinity over infinity there. So I'm going to apply my L'Hopital's rule, and I get that this is equal to the limit as x goes to negative infinity of the derivative of the top is 3x squared. The derivative of the bottom involves the chain rule, and we end up with minus 3e to the minus 3x. It was e evaluated at minus 3x, but then times the derivative of the inside, and the derivative of the inside is minus 3. And if I evaluate again, I can also cancel my 3's here. And in going to apply that limit, I end up with minus infinity times minus infinity is positive infinity. And e to the, and then we have minus here, e to the minus 3 times minus infinity is positive infinity. And I end up with e to the positive infinity, and that is going to be infinity. And so I still have L'Hopital's rule applies again. And so I keep going with it. So I'm going to take my limit as x goes to minus infinity, and I'm going to take my derivative, and my derivative is 2x. And the derivative of the denominator, that minus 3 also comes out, and it turns into a positive 3, and we have e to the minus 3x. And applying my limit, I'm going to 2 times negative infinity, which is negative infinity, over 3 times negative 3 times negative infinity is positive infinity, and e to the positive infinity is infinity, and so we still end up with infinity over infinity. Dang, we have L'Hopital's rule again. So we get to do it again. And I'm going to take my limit as x goes to minus infinity. The derivative of the top is 2. The derivative of the bottom is minus 9 times e to the minus 3x, and I'm going to apply my limit. 2 is going to 2, and minus 9 e to the positive infinity is infinity, and 2 divided by infinity is going to 0. So my limit here is 0. All right. So that does it for part A of indeterminate products. What's next is indeterminate differences. So I will see you in the next video. Cheers.